Hello everyone, this next lesson is on aldehydes and ketones. So we've finished talking about alcohols and we're taking it, the next step naturally would then be aldehydes and ketones, which look like this. So this is the general form of an aldehyde, where we have a general R group, another extension of a hydrocarbon, and we have a terminal carbonyl. So the C double bond to O is generally referred to as carbonyl. Right, where R can be a hydrocarbon or a hydrogen. Okay, and a ketone is similar to an aldehyde, except the hydrogen it can't be hydrogen at this end here. It isn't a terminal carbonyl. It is one within or between two other carbons. So when it's not terminal, it's a ketone. When it is an aldehyde. Okay, so here, it's just asking us here to circle the aldehyde functional group and circle the ketone functional group. So again, the aldehyde functional group is found when you have a carbonyl, a terminal carbonyl. So at the very end, there is this carbonyl that makes it an aldehyde. So that's your aldehyde. And your ketone, non-terminal between two carbons, found right here. That is your ketone. Okay. Now, rules again, I will review the first couple. Some other rules that are added onto these will appear as we do more examples, or as we get into the examples. So when you have a terminal carbonyl, that means it's going to be an aldehyde. You take the E out of the ane, ene, or ine, and you add al. We'll get to those examples. If it is a central carbonyl, so not an aldehyde, instead a ketone, you take out the E and you add not one, but you add one. So we'll get to those examples as well. We'll need to also look at a priority list, a functional priority list with increasing priority or decreasing priority, I should say, from top to bottom. That will be important to start to look at since we're learning more and more functional groups every day. Here is that list. Now I've highlighted the functional groups that we have done. Look, we've done a lot of them. Well, today we will, or in this lesson, we'll do aldehydes and ketones. We recently finished alcohols. We've done alkenes, alkenes, alkanes and alkyl groups, and also looked at alkyl halides. And this is the priority. So right now, aldehydes take top priority, followed by ketones and alcohols, and so on. Okay, now examples, nomenclature examples. So here, whenever you see a carbonyl, you first ask yourself, is it terminal or is it central? In this case, it's terminal, so it's going to be an aldehyde. So the end is going to be Al. And then we see that there are two carbons here, so it's going to be not ethane, but ethanal. And you don't have to actually number it because if it's a terminal carbonyl, it's assumed that it's on the first carbon. So you don't need to write one ethanal. It's just kind of repetitive if you do. If it's a central carbon, in other words, or rather a central carbonyl, in other words, a ketone, you change the ending to -one. 1, 2, 3 in propane, then we have a central carbonyl. It becomes propanone. Now here there is a 2 propanone. There doesn't have to be if it's implied. There really is no other place to put a carbonyl without making it into an aldehyde. So propanone can just be said to be propanone, or this molecule can just be said to be propanone. But here is that locant. Okay, now getting slightly more challenging here. We're going to decide, should we start numbering on this end or on this end? First, look at your priority group, which has a higher priority, right? We have our carbonyl, our aldehyde terminal carbonyl group here, so an aldehyde or an alcohol, according to the priority list. It's going to be the aldehyde that determines priority, so it's going to end in al, but not just that, you begin numbering right here. So this is carbon 1, carbon 2, carbon 3, and carbon 4. Starting to number on this end, you have, therefore, an aldehyde. Here you continue with the carbon chain, 1, 2, 3, then you have an alcohol that doesn't take priority, so you don't end it with all, and you continue with the fourth carbon along the end. Now this is where I'm going to star this because an addition to our 3 or 4 rules has to be made here. Whenever you have an alcohol as a non-priority functional group, right, non-priority, so it doesn't change the ending to OL, all, That then is called something different. It's called hydroxy. So it being on the third carbon is then 3-hydroxybutanal. Butanal for the 4 carbons, ending with an Al because of the terminal carbonyl. Okay, continuing. Here we have an interesting case. We have 1, 2, 3, 4, 5, 6. We have a 6 carbon ring here, an alkene benzene looking compound, or aromatic compound, and this has 6 carbons. You would think then that this could be the parent, but remember we don't. We have to make sure, we can't say that this is the parent. We have to make sure that the parent includes as many functional groups as possible. So here is our terminal carbonyl group, our aldehyde. Off of our second carbon we have our double bond, which is going to add an ENE somewhere, and we have a halogen here as well. On the third carbon, 2 things are happening. We have a halide and we have this functional group as a branch. Benzene is not benzyl, it is phenol. So 3 things to take into account here, 4 actually: the halogen, the phenyl group, the double bond, and our terminal carbonyl, our aldehyde, off of a 3-carbon parent chain, which would normally have been called propane, but now it's going to be propene, also ending in Al. So let's see how we can place that all together. So there is the Al, right? And then we have propene, al, notice the E, not propane. Okay, so propene al. We have to say where that double bond is. It appears on the second carbon right here. Off of our third carbon, we have 2 branches. We have a halogen, a chlorine, so that's chloro, and we have phenyl. Right, so 3-phenyl, 3-chloro. Okay, list your branches. That's off the third carbon in this case. List your branches in alphabetical order. C comes before P. So it's 3-chloro, 3-phenyl, 2-propene al. Again, you don't have to put the 1 in here and break up the parent because it being a terminal carbonyl implies that it exists off the first carbon. Okay, another example. You can name this, I'm sure you can. With the examples we've done so far and a little bit of time, I think you can name this. So this timer reminds me that if you'd like, I actually suggest you do pause the video, take a minute or two, try to name this, and then see what the answer is on the next slide. So take that moment to pause the video now. Okay, hopefully you've paused the video and you're now playing it again. We can go over this. And before I move on to the next slide showing you the answer, let's just analyze this ourselves. So here we have highest priority group is a terminal carbonyl, so it's going to be an aldehyde. So we know it's going to end in Al. Carbon 1 therefore will be this carbon, 2, 3, 4, and 5. It doesn't really matter if you go 5 up here or 5 below, it gives you the same name. So first carbon, we have a terminal carbonyl. Second, we have a methyl, so we're going to have 2-methyl as a branch. Off the third carbon, we have an ene, right? Double bond here. Double bond. We write that down. So 3-ene. We'll put this together all together later. Off the fourth carbon, we have another methyl group. All right, so there are 2 of the same methyl group, so we know we're going to use di. We're going to use di. We're going to have an ene and an al all around the parent. Parent 5 carbon is going to be pentanal. Okay, so this will become, and it's not going to be ane because there's a double bond, so pentenal. Where on the third carbon we have that ene. Okay, so now that we've analyzed it, let's put it all together, and here's the answer. 2,4-dimethyl, 3-pentenal. And these arrows point to the parts of the molecule that each of the parts of the name are referring to. Okay, next we have following examples, F, G, and H. This cyclic alkane has a carbonyl. Notice there's nowhere along this carbon backbone or the cyclic carbon chain here where you can put a terminal carbonyl, so it has to be a ketone. So it'll be cyclohexanone as your first ketone example. Okay, here we have 1, 2, 3, 4, 5, 6. 6 carbon, this has to be carbon 1. It is going to be an aldehyde, so it's going to end in al. No need to number that because that has to be number 1. So it's going to be hex and al. Oh, I said hexanal. No, it's hexenal because off the 5th carbon we have that double bond. So watch out for that locant, 5. There we go. Then we have 1, 2, 3, 4 alcohols. And when an alcohol is not the highest group or the priority group, it's named as a branch. And when an alcohol is a branch, it's not all, OL, it's hydroxy. But because there are 4 of them, we have to say tetra and state the locants. So the locants are 2, 3, 4, 5. Therefore, this is the name. 2, 3, 4, 5 tetrahydroxy 5-hexenal. Okay, take a minute, see if you can answer this next one yourself. I will reveal the answer. Pause the video and see what answer you came up with. So for H, go ahead. Okay, so hopefully you've come up with the answer and you're continuing the video. Here we have a carbon chain that is 3 carbons long. Yes, this butyl group is longer or is greater, but we want to include as many functional groups as possible along the parent, so we choose the shorter end. Here it's 1, 2, 3 propane, you might think, but take a look at the terminal carbonyl. It's going to be an aldehyde, so it'd be propanal. Notice I didn't say propenal because unlike other cases, this is a fully saturated carbon chain, so it's going to be propanal. There we go, propanal. Now, a couple more things happening. Off the 3rd carbon, right off the 3rd carbon, we have a carbonyl group that doesn't take priority. Remember our priority list, aldehydes beat ketones. Also off the 3rd carbon, we have a cyclic butane, which if it's a alkyl branch, which it is, you don't say butane, you say cyclic butyl. Or cyclobutyl, I should say, cyclobutyl. Okay, and that both of them exist off the 3rd carbon. So the only new part here, and I've stated the addition to our rules here is that you were going to add a prefix or add the name for this central carbon or non-terminal carbon when it doesn't take priority. I know it's going to look a bit funny, but this is the name. 3-cyclobutyl, okay, that part should be okay. That part should be fine because that's referring to things you've seen before, this alkyl, the cyclic alkyl group, so 3-cyclobutyl. 3-oxo, this is the new part. When a non-terminal carbonyl is not a priority group like it is in this case, because the aldehyde's priority, you name it like this. You write oxo, O-X-O. So off the 3rd carbon, you have an oxo right here. Off a parent, that is propanal, and that's the name. Rule summarized at the bottom. Okay, now we're continuing with properties of ketones, and this video has been a little bit longer, so I'm going to pause here, and I'm going to do a second part to the video, and we'll call it part 2 of the same lesson. Don't want this video to go on for too long. That can be a bit too long to listen through. So we'll stop after this, and I'll make another video for you to refer to. Okay, let's talk about properties of aldehydes and ketones. So they have lower boiling points in their alcohols. Now, if you think about that, we'll quickly draw what one might look like and compare it to the other. So an alcohol. 1, 2, 3. Propanol, compare that to, right? 1, 2, 3. Propanal. Notice without that hydrogen, you don't have hydrogen bonds. Yes, you do have a very polar end. You do have a dipole-dipole interactions happening there, but you don't have that hydrogen bond. So lower boiling points than alcohols. Because you don't have that OH, it can't form hydrogen bonds. Okay, they are generally miscible with both polar and nonpolar solvents, such as water and oil, because you do have that polar end here, and a portion of the molecule is often going to be nonpolar as well. So it's generally miscible in both. Also pretty reactive, because you have that around that carbonyl, you have lone pairs of electrons just sitting there, as well as a double bond here, which we know to be generally more reactive. Again, more details in the next unit. Okay, we'll get into reactions in part 2, so stay tuned for that.